and welcome to today's lesson. We're going to be covering topics under the Study Island lesson called Systems of Equations and Inequalities in Algebra 2. And I'm going to be showing you how to do these problems on the TI-84 Plus calculator. There is one skill you're going to have to know how to do on paper and pencil in order to do it in the calculator, and that's how to write any equation into y equals form. So to set it equal to y. Everything else, I'm going to be showing you how to do these problems straight on this graphing calculator. And these questions also come from the standard 2.2b and c in Algebra 2. So this question here gives me two equations, and it wants to know which one of these four choices does it represent. So my first step is going to be to go to y equals, so I'm going to press the y equal button to solve this equation. And for my cursor's blinking here at y1, and that's where I'm going to enter my first equation. So that the calculator knows for sure that 1/2 is a fraction, I'm going to put it in parentheses, so 1 divided by 2 in parentheses. And then I press X, which is this button right here beside the green alpha button. And then I press 1. And then I scroll down, and now I'm going to put in negative x for the second equation, and I'm going to put it right here at y2. And make sure that you use the negative button and not the minus button, because the calculator isn't smart enough to know the difference. So I'm going to press negative x plus 7. And now I'm looking at my answers here, and I notice that on the x-axis, the answers go from negative 8 to 8. And the y-axis also goes from negative 8 to 8. So to get my graph to exactly match, I'm going to press Window and make sure that my x min and max are negative 8 and 8, and that my y min and max are negative 8 and 8. The default here is negative 10 and 10, so most likely you're going to have to change it. And then I go ahead and press Graph, and there it is graphing my answer. So I'm looking here, and I'm looking for an answer that looks like my screen over here. So they're intersecting in the first quadrant. So let's see how many answers we have intersecting in the first quadrant. So W is intersecting in the first quadrant, but X is intersecting in the second quadrant. So it can't be X. Y is intersecting in the third quadrant, so it can't be Y. Z is intersecting in the first quadrant also, so it could be W or Z. And so I look at my lines here, and they cross the y-axis at 7 and 7, which this one crosses at 7 and 7, the y and x-axis, and this one here is crossing the y-axis between 0 and negative 1, and the x-axis between 0 and 1. That isn't the case on the screen, so it can't be Z. So let's go back to W. W, that line crosses the y-axis at 1 and the x-axis at negative 2, which it does on the screen also. And then my blue line also crosses at 7 and 7. So the screen perfectly matches W, which is going to be my final answer of D. This next question is going to be similar. It's just now I'm dealing with parabolas instead of lines. So I'm going to go back into y equals and clear out what I have typed in there. And then I'm going to type in my first equation into y1. So I'm going to do negative x squared plus x plus 6. And then I'm scrolling down, and I'm going to type in 1/4. So I do parenthesis 1 divided by 4 in parenthesis x squared. And then minus 4. And so then once again, I notice that my window is from that negative 8 to 8, so I've already reset that, so I don't have to do it again, and I can just press Graph. And there's my first parabola, and there's my second parabola. Okay, so this first parabola, if I count, because each of these tick marks is 1, that's what the scale means in the window. So I have 1, 2, 3, 4. It crosses the y-axis at negative 4. And then if I count up, it crosses the upside down parabola here crosses the y-axis at 1, 2, 3, 4, 5, 6-ish. So I look here, and negative 4 and 6, that's not where the parabolas are crossing the y-axis, so it can't be w. On x, negative 4 and 6, that is where they're crossing. And those screens look pretty similar, so it most likely is x, but let's double check the other choices. Here at y, negative 4 and 6, I have 1 crossing at 6, but not at negative 4, so it can't be y. And then z, it's crossing at negative 4, and it's also crossing at 6, and those ones look kind of similar too. So let's see, how can we tell the difference between x and z? So next, let's look at where they're intersecting the x-axis to see if that rules anything out. So if I count over negative, I have negative 1, negative 2, negative 3, negative 4. So it crosses at negative 2 and negative 4. And then I have 1, 2, 3, 4. It crosses at positive 3 and positive 4. So here it's crossing at negative 2, negative 4, positive 3, and positive 4. So x here is the x-intercepts are all the same as what's on the screen too. Whereas z, instead of being negative 2, it's negative 3. Instead of being positive 3, it's positive 2. So it can't be z. So that means my final answer is going to be x, which is choice D. In this next equation, we're going to be looking at inequalities. So like I said before, in order to enter in the calculator, it has to be in the form y equals mx plus b. So you might have to rewrite the equation first, if need be. And then the other thing you're going to need to know is if it's a greater than or greater than equal to, you're going to shade above the line. If it's a less than equal to or a less than, you're going to shade below the line. This is for inequalities only. And then if you'll have a solid line if it has the equal to part, and you'll have a dashed line if it's just a greater than or less than, because the calculator isn't going to tell you solid or dashed. And you have to tell it to shade above or below. So let's go ahead and look at an example. So here's my example. So I'm going to go into y equals, and the first step is I'm just going to enter these like I would if it was an equal sign instead of a greater than, an equal to, and greater than. So I'm going to clear this and put in 1/3 x, so parenthesis 1 divided by 3, parenthesis x, minus 4. And then I'm going to put in the second one, so negative 3x plus 2. And so now I have to tell it how to shade. So to do that, on this line over here beside the y1 and y2, I'm going to go over there until it's highlighted. And I'm going to start with y1 so you can see it's blinking. My first equation is a greater than symbol, so I need to tell it to shade above. So to do that, I'm going to press enter until I see in front of y1 blinking here the line that has shading above it. So enter, I have a thick line, and then here you can see there's a line and shading above it. That's the symbol I need to put for greater than. And then I'm going to scroll down in front of y2 and do the same thing. It's also a greater than, so I'm going to have that same symbol. And I press enter twice to get it. And so now I'm telling the calculator that these are both greater thans when I go to graph it. So once again, I still have that window of negative 8 to 8, so I'm not going to mess with the window at all. I'm just going to go ahead and press graph. And when I do that, there's the shading. The only thing is that this calculator is always going to use solid lines. You have to know that the second one is a dashed line. That's just one thing the calculator isn't able to do that you have to know. So the second one that it graphed was this one here. I need to know that that's a dashed line in my answer. So here the overlapping is in the upper right corner. So I'm looking for overlapping in the upper right corner, which W has, but y and z and x do not. So that means W is going to be my answer. It has the right line dotted also. And so W is going to be my answer, which is choice A. Now this problem here is asking us to solve the system of equations, and it tells you to do it by elimination. However, it's multiple choice, so your work isn't getting checked. So you can go ahead and use the graphing calculator to do this if you know how to write these in the forms of y. And it's a really good skill to know if you're relying on the graphing calculator a lot to help you with these problems. So it is something you might want to practice. So I've gone ahead and wrote these two equations over here on this piece of paper, and I'm going to solve them both for y. So my first step is to subtract the x term from both sides. So these x's cancel out, and I'm just left with the positive 4y equals 47 minus 7x. Because this is a number and this is an x, I can't combine them. And then my next step is going to be to divide every term by 4. So that means it's going to divide by 4 3 times. So these 4's cancel out, and the calculator is smart enough to deal with improper fractions. So I'm just going to leave the rest of the equation with improper fractions, like that. So that's going to be one equation that I type into the calculator. And then I do the same thing with the second equation. I subtract 4x from both sides. Here they cancel, and I'm left with the positive 5y equals 35 minus 4x. And then I divide every term by y's coefficient, which is 5 here. And here the 5's cancel, and y equals, here I can actually do 35 divided by 5 is 7, so I'll go ahead and do that. And then here I'm just going to leave 4 over 5 as the coefficient in front of x. And that's going to be the second equation I type into y equals. So I'm going to go to my y equals, clear out what I have there, and then I'm going to type my first equation here into y1. So that's going to be 47 over 4, which I use parentheses around it, minus 7 divided by 4, and I use parentheses around that also, x. And then I'm going to go ahead and type in my second one, which is 7 minus, and then parentheses 4 divided by 5, and parentheses x. And now I'm ready to go ahead and graph those. So since this one doesn't give me a window, I'm going to go ahead and press zoom standard to get back to the negative 10 to 10 window. And there I see where the lines cross. Wherever the lines intersect is going to be my answer. So I can tell the calculator to calculate that intersection by using this calc feature right here. So since it's in blue, I'm going to have to press second calc, and I want it to calculate the intersection, so I'm going to choose choice 5, and it asks me where's the first curve. And so I'm looking for I'm using the buttons to get this spider that's blinking here over a curve. And so I'm going to press enter to tell it that's my first curve. And then I need to put it on the second curve, which is going to be the second line here. So I'm going to use my arrow buttons until I see it. And there it's flashing right here on that second line, so I'm going to press enter. And then the next question it asks me is to guess where the intersection is. So I'm just going to use my right and left arrows to get it as close to the intersection as I can. So there it's blinking over the intersection, and I'll press enter. And it tells me the intersection is x equals 5 and y equals 3, which is choice D, your final answer. Here is another question that you can do the exact same way as the last problem, only it has x squared, so you type them into y1 and y2. And you could press graph and then do the second calculate. However, another way you could do this is to use the table feature. So I'm going to press second table. And if I notice here, my x choices for the first point are 4 or negative 4. So I scrolled up until I had 4 in the x column. And I look at 4 and I have the same number for both y columns. So that means that is going to be where it intersects. And 4, negative 8 is going to be one of my answers. So it could be A or B. And so I need to do the same to see if it's 6 or negative 6. So I already have 6 here on the screen. And both the y's are also the same. So that means that's going to be my second intersection at 6, 4 because the y's matched. So that means letter A is going to be my final answer. Thank you for joining us today, and I hope you learned something.